What if I told you that the strongest and most durable houses in American history were built by people who could neither read nor write and had never seen a blueprint? Armed with only a single tool and a deep understanding of nature, these people built entire settlements in the wilderness, creating engineering masterpieces without a single nail or measuring tape. Their houses stood for decades, withstanding hurricanes and blizzards, while modern buildings require constant repair. They were true frontier engineers whose knowledge is now almost completely lost. Watch this video to the end, and you will learn how, with just an axe, it was possible not only to cut down a tree, but also to carve perfectly straight beams, how absolutely straight walls were erected without a level or plumb line, and what secret ingredient added to ordinary clay made it stronger than modern cement. What if I told you that the most sophisticated architectural solutions were not born on paper, but directly in the mind of a builder standing in the middle of a wild forest? For the pioneer settler, the main blueprint was the land itself, and the main architect was centuries of experience passed down by word of mouth. These people did not think in terms of plans and diagrams. They thought in terms of harmony with the surrounding world. Building a house was not a conquest of nature, but a dialogue with it, where every tree, every stone, and every stream had its own voice. It was a philosophy of creation, not simple construction. The knowledge they brought with them had deep roots in the forests of Scotland, the mountains of Germany, and the fjords of Scandinavia. Each culture contributed to the common pool of frontier wisdom. The Scots and Irish were masters of stonework, creating strong and reliable foundations. The Germans brought with them the art of tightly fitting logs and complex carpentry joints that did not require nails. The Scandinavians taught everyone the art of creating warm and durable roofs from simple wooden planks. These builders perceived the future house as a living organism, not as a soulless box made of wood and stone. They knew that felled wood continues to breathe and move, settling and changing its shape over several years. Therefore, the entire structure of the hut was dynamic, capable of adapting to these changes. Each groove and each joint was designed to become stronger and tighter over time, creating a windproof and reliable wall. The key skill of such an engineer was not the ability to calculate, but the ability to see and feel the material. He could determine the density, moisture content, and presence of hidden defects simply by tapping the tree trunk with the back of an axe. He could determine the ideal curvature of a log with a glance so that it would fit into the wall with minimal gaps. This was intuitive knowledge, honed by years of practice, which no measuring instrument could replace. They did not seek to level the ground for construction by tearing down hills and filling in ravines, as we do today. Instead, they integrated the house into the existing landscape, using the uneven terrain to their advantage. A house built on a small slope had natural drainage. A hut nestled at the foot of a hill was protected from cold winter winds. It was architecture based on common sense. Each stage of construction was filled with meaning and tradition, choosing the first tree, laying the first stone in the foundation, installing the ridge beam. These were not just technical operations, but rituals that connected a person, their home, and the land into a single whole. They were not just building a shelter from the weather, they were building their new world, their place in the universe. The construction process was not quick. It required patience and methodicalness, qualities that modern society has largely lost. Each log was processed by hand. Each groove was carved with jeweler's precision. They did not have the opportunity to correct a mistake by buying new materials. Any mistake meant weeks of wasted labor, so every swing of the axe was measured and deliberate. Thus, the frontier cabin was not just the result of physical labor, it was the embodiment of cultural memory, deep respect for nature, and incredible human ingenuity. These builders did not have engineering degrees, but their creations, still standing in the American heartland, are the best proof of their supreme craftsmanship, passed down through generations. Modern engineering relies on precise calculations and standardized materials, while frontier builders relied on experience and intuition. We would love to hear your opinion. Which approach do you think is more reliable in the long run? Write about it in the comments and be sure to subscribe to our channel so you don't miss other stories about forgotten technologies. Are you ready to learn the secret that determined not only the strength of the house, but also the lives of an entire family of settlers? Choosing a location for construction was the first and most important decision a pioneer had to make. A mistake at this stage could have catastrophic consequences, turning the dream of a new life into an endless struggle for survival. It wasn't just a matter of finding a flat piece of land, it was a complex analysis of the terrain, taking into account dozens of factors invisible to the untrained eye. The first and foremost rule was access to water. Settlers looked for a place near a stream or river, but never built a house too close to the shore. They intuitively understood the danger of spring floods and knew how to read the traces of past floods from the silt deposits on trees and stones. The ideal location was considered to be on a small hill, a few hundred meters from the source, which provided both access to water and safety. The second factor was the forest. It was the main building material and source of fuel. Settlers assessed the quality and species of trees. Preference was given to straight and tall pines, spruces, or oaks, which were easy to work with. At the same time, they tried to choose a location so that they would not have to drag heavy logs too far. The ideal location was on the edge of the forest, where there was access to wood on one side and an open space for a future field on the other. The orientation of the house was of great importance. The entrance to the hut and most of the windows were placed on the south or east side. This allowed the sun's heat to be used to warm the house in winter and catch the first rays of the sun in the morning. The north side, the coldest and darkest, was often left blank, without windows. And it was on this side that trees were planted to protect against the winter winds. Wind protection was critically important, especially on the Great Plains, where there were no natural barriers. Settlers sought places sheltered by hills, ravines, or small groves. They understood that the right location could significantly reduce the need for firewood in winter and make life in the hut much more comfortable. It was passive energy efficiency based on observation. Soil drainage was another key element. Builders avoided low-lying and marshy areas where water accumulated, leading to dampness in the house and rotting of the lower logs. They preferred sites with a slight slope and sandy or rocky soil that drained rainwater well. This simple rule saved them from many problems in the future. In addition to practical considerations, social factors were also taken into account. Although settlers valued privacy, they tried to settle within a few miles of their nearest neighbors. This was important for mutual assistance, for working together on heavy tasks such as raising walls, and for general safety. The location relative to future roads and trails also played a role in the choice of site. They knew how to read the land like an open book. The type of vegetation told them about the fertility of the soil. The presence of certain types of trees indicated the depth of the groundwater. The behavior of a stream at different times of the year suggested how reliable it was as a source. All this knowledge was the result of careful observation and experience accumulated over generations. The selection process could take several days or even weeks. The settler would walk around the area, make mental notes, observe the movement of the sun and the direction of the wind. It was as if he were having a dialogue with the terrain, trying to understand its character and find the one place that could be called home. It was an act of deep respect for nature. Thus, the choice of location was not a matter of chance, but a precise science based on a deep understanding of the ecosystem. Everything depended on this first step, whether the house would be warm and dry, whether there would be a harvest in the fields, and whether the family would be safe. What do you think modern urban planners could learn from this experience? But choosing a location was only the beginning. The real magic began when the only tool capable of turning a forest into a house was picked up. Ready to find out how this was possible? I will reveal to you the most closely guarded secret of frontier engineers: how a single piece of sharpened steel replaced an entire arsenal of modern construction tools. The axe in the hands of a settler was not just a tool for chopping wood. It was an extension of his arm and mind. a universal tool with which he could perform up to 90% of all the work involved in building a house. Axe handling was a high art, learned from childhood and perfected throughout life. There were several types of axes, each with its own purpose. A heavy felling axe with a long handle was used to fell trees. Its blade was slightly rounded, allowing it to cut deep into the wood and effectively sever the fibers. An experienced lumberjack could fell a huge tree with remarkable precision, directing its fall exactly where it was needed. After the tree was felled, a carpenter's axe, or adze, was used. This tool had a wide, almost straight blade sharpened on one side. It was used to strip the bark from the log, and most importantly, to turn the round log into a straight beam. This process was called hewing and required incredible skill and physical strength. The process of hewing was a true art. First, transverse cuts were made on the log to the same depth. Then, standing on the log, the builder used powerful and precise blows with an adze to chip away the wood between the cuts, moving along the trunk. The result was a surprisingly flat and smooth surface, which today can only be achieved with a sawmill or electric planer. For finer work, such as cutting grooves and joints, a small hand axe or hatchet was used. This tool was light and maneuverable, allowing for almost jeweler-like precision. It was used to carve complex dovetails and other lock joints that held the logs together at the corners of the hut without a single nail. The axe also served as a measuring tool. The length of the handle or the width of the blade were often used as a standard of measurement. By making notches on the log, the builder could measure the required length with sufficient accuracy for construction. He did not need a tape measure. His eye and his trusty axe were the best measuring instruments. The rhythm of working with an axe was meditative and measured. The blows were unhurried but powerful. Each blow was carefully thought out because it was almost impossible to correct a mistake. This work required not only strength but also extreme concentration. The builder and his tool became one, working in harmony with the material. It was the axe that shaped the unique appearance of the frontier cabin. The marks left by the axe on the walls, still visible today, tell the story of its creation better than any book. They are a testament to hard manual labor, craftsmanship, and an era when a person could build a house with only a single tool in their hands. Mastery of the axe was a symbol of independence and self-sufficiency. A person who knew how to use it could survive in any wilderness. They could build a home, make furniture, craft tools, and provide themselves with fuel. The axe was the key to life on the frontier. If you enjoyed this story about a forgotten craft, please like this video.
The logs stacked tightly provide natural drainage, preventing dampness from entering the cabin and protecting the house from the primary threat of moisture.
What if everything you've been taught about foundations is outdated? Modern construction is unthinkable without deep excavations and tons of concrete. However, frontier engineers knew a secret that allowed them to build incredibly stable houses without a single drop of cement. Their approach was not only simpler and cheaper, but in many cases much better suited to the conditions of the wilderness, protecting the house from the main threat: dampness. Instead of a continuous strip foundation, which would have been impossible without industrial materials, the settlers used a columnar or point foundation. They installed supports only at the most important points, at the corners of the future log house and at the intersections of the interior walls. This was sufficient to evenly distribute the weight of the massive log structure and ensure its absolute stability. The main material for the foundation was large flat stones, which could be found in abundance on any site. Settlers chose the largest and strongest boulders capable of supporting a weight of several tons. They did not bury them deep in the ground, but placed them directly on the surface, only slightly clearing and compacting the soil beneath them. The most difficult task was to level these supporting stones horizontally so that the future house would not stand crooked. They did not have laser levels, but they had ingenuity. The simplest level was a regular wooden trough filled with water. By placing it on adjacent stones, they achieved a perfect horizon by adding or removing soil under the supports. This method was simple, like all genius ideas. The main advantage of such a foundation was that it raised the entire wooden structure above the ground. The bottom log, or sill plate, never came into contact with the damp soil. This ensured constant air circulation under the house, preventing the wood from rotting and significantly extending the life of the entire structure. This type of foundation was also resistant to ground movements caused by freezing and thawing. While a solid concrete foundation could crack due to frost heaving, the point supports simply shifted slightly without damaging the entire structure. The house seemed to float on these stone islands, adapting to seasonal changes. In regions where stone was scarce, such as the Great Plains, the strongest and most rot-resistant types of wood were used as supports. For this purpose, thick stumps of oak, cedar, or larch were used. The lower part of such a pillar was burned on a fire, creating a layer of charcoal that served as a natural antiseptic and protected the wood from moisture and insects. The process of laying the foundation was slow and painstaking. It required physical strength to move huge boulders and precision to align them correctly. The strength and durability of the entire house depended on the quality of this work. The settlers did not rush, understanding that a solid foundation was the key to future prosperity. After the supports were installed, the first, thickest, and strongest logs were laid on top of them. They were treated with special care as they bore the entire load. This first crown determined the geometry of the entire log house and had to be perfect. Thus, the foundation of the frontier hut was a model of rationality and a deep understanding of the laws of physics and nature. It was simple, effective, and perfectly adapted to the available materials and conditions. How important do you think a solid foundation is for any endeavor, not just construction? In the next chapter, we will reveal the main secret of the log cabin's strength, the art of joining logs without a single nail. The heart and soul of any log cabin was its corners. This is where the builder's highest skill was evident, his ability to turn simple logs into an indestructible fortress. The entire structure was held together not by nails or staples, which the settlers simply did not have, but by the force of friction and the precise geometry of wooden locks or notches. It was a complex three-dimensional puzzle where every detail had to fit into place with perfect precision. There were many types of corner joints, and the choice of a particular type depended on the type of wood, climate, and traditions brought by the builder. The simplest and most ancient was the bowl joint. A semicircular notch was carved into the upper side of the lower log, into which a perpendicular log was placed, like in a cradle. This joint was simple to execute, but left the ends of the logs protruding, which required more wood. A more complex and sophisticated joint was the claw or dovetail joint. The ends of the logs were cut into a trapezoidal shape resembling a swallow's tail. This joint was much stronger and left no protruding ends, which made it possible to sheathe the house with boards in the future. But most importantly, as the log house settled and the wood dried, such a lock became more and more wedged under its own weight, making the joint incredibly tight and airtight. The marking of such a complex joint was done without any measuring instruments, by eye. The master mentally imagined the shape of the future lock, and using an axe and a chisel, began to remove the excess wood. He constantly applied the logs to each other, checking the accuracy of the fit. It was a job that required not only a steady hand, but also impeccable spatial imagination. The process of carving the lock was slow and meditative. The builder had no room for error. Too large a gap would weaken the joint and let in the cold. Too tight a fit could cause the wood to crack as it settled. It was necessary to find the perfect balance, which only came with years of experience. Each log in the log house was unique. They were not calibrated like modern building materials. Each had its own thickness and curvature. Therefore, the builder could not simply cut identical locks. Each subsequent log was individually fitted to the previous one, taking into account all its characteristics. It was manual work in the highest sense of the word. In addition to corner joints, there were other types of joints. They were used to connect logs along their length if there were not enough of them for the entire wall, as well as to cut beams for the floor and ceiling. All these joints were also made without a single metal fastener, only thanks to the precise geometry of the grooves and tenons. This art was the result of centuries of evolution in wooden architecture. Each joint was refined to absolute perfection by generations of nameless craftsmen. They created structures that could stand for centuries, becoming only stronger over time. It was engineering based on a deep understanding of the properties of wood. When all the logs were fitted and laid, the corners of the hut formed a monolithic structure. They were so strong that they could withstand any load, from hurricane-force wind to the weight of snow on the roof. It was a simple but ingenious system in which each element supported the other. Thus, the secret of the frontier cabin's strength lay not in strength, but in wisdom. In the wisdom of choosing the right joints, in the precision of their execution, and in understanding how wood lives and breathes. These were not just joints, they were true works of carpentry hidden within the walls. Guess how much time and manpower it took to turn a pile of processed logs into a real house? The process of erecting the walls was the culmination of all the preparatory work. It was the most labor-intensive and responsible stage, requiring not only skill, but also the coordinated work of an entire team. It was here that the spirit of the frontier, the spirit of mutual aid and collective labor, was fully manifested. Lifting heavy, wet logs to human height, let alone higher, was impossible alone. Therefore, all the neighbors in the area gathered for the construction of the walls, or log raising. It was a big event for the entire community. The men worked together, lifting and laying the logs, while the women prepared food and looked after the household. Simple but effective devices were used to lift the logs. 2 sloping poles, or skids, were placed along the wall. Heavy logs were pulled up these guides using ropes. This required enormous physical effort and complete synchronization of actions. The team had to work as a single mechanism, obeying the commands of one, the most experienced builder. One of the main tasks in erecting the walls was to keep them vertical and of equal height. Since the logs had a natural taper, i.e., they were thicker at the butt and thinner at the top, they had to be laid alternately with the thick and thin ends. This compensated for the difference in diameter and kept the walls even. But the main secret of the dense, windproof walls was the longitudinal groove technology. After laying another log, a semicircular groove was carved into its underside. This groove had to exactly match the shape of the upper part of the lower log. As a result, the upper log did not simply lie on the lower one, but sat on it with its entire length, leaving no gaps. A special tool similar to a compass, called a scraper, was used to mark this groove. One leg was guided along the lower log, while the other traced a precise line of the future groove on the upper log. Then, using an axe and a chisel, the wood was cut along this line. It was painstaking work that required absolute precision. As the walls grew, the work became more difficult and dangerous. The logs had to be lifted higher and higher. People worked on unstable scaffolding, risking falling down. That is why teamwork and the experience of the leader were crucial. Any mistake could have serious consequences. In one day of such collective work, the walls were raised to their full height. By evening, the skeleton of the future house stood on the site of the empty foundation. It was a moment of shared joy and pride. People saw the real result of their joint labor, which strengthened not only the walls of the house, but also the bonds between neighbors. This custom was not just a way to get hard work done. It was the basis of the social structure of the frontier. Families scattered over long distances depended on each other. Today you help your neighbor build a house, and tomorrow he will help you harvest your crops. What does the concept of good neighborliness mean to you today? In the next chapter, we will learn how these mighty walls were turned into warm and cozy homes.
This stew is one.
The walls made of massive logs looked impressive, but on their own they could not protect against the piercing wind and winter cold. Despite all the carpenter's tricks, there were still small gaps and cracks between the logs. Turning a log cabin into a warm dwelling required another important technological step: sealing, or, as it was called, chinking. This process consisted of 2 parts: filling the gaps and then sealing them. The first part of the process was called chinking. Its purpose was to tightly fill the main gap between the logs with some kind of elastic material. The choice of material depended on what was available in the area. Most often, dried moss was used, which, like a sponge, could expand and contract with the logs while retaining its thermal insulation properties. In forested areas, wood shavings, tow, or even thin wooden slats were also used to fill the gaps. The main requirement for the material was that it had to be elastic and retain heat well. This filler was tightly packed into the gaps using a special wooden hammer and spatula, creating a primary insulating layer. However, this filler alone was not enough. It could absorb moisture and deteriorate over time. Therefore, a second protective layer called daubing was applied on top of it. It was a kind of plaster that sealed the joint, protecting it from wind and rain. The recipe for this mixture was one of the main secrets of every builder. The basis for this plaster was ordinary clay, which was mixed with sand and water until a plastic mass was obtained. However, in its pure form, such a mixture would be fragile and would crack after drying. To avoid this, a reinforcing component was added to it. Horsehair, crushed dry grass, or straw were used as reinforcement. These fibers, like reinforcement in concrete, bound the clay mass, making it strong and resistant to cracking. Sometimes lime or wood ash was added to the mixture, which served as an additional binder and antiseptic, preventing the appearance of mold. The finished mixture was thoroughly kneaded, often simply with the feet, until a homogeneous consistency was achieved. The resulting mass was carefully applied over the insulation, filling all the gaps and forming a smooth, slightly convex seam. This work had to be done in dry weather so that the mixture could dry evenly. After drying, it turned into a durable, waterproof, and windproof barrier. This process required constant renewal. The wooden log house breathed and settled during the first few years, which could cause cracks to appear in the sealant. The owners had to regularly inspect the walls and reapply the sealant to keep their house in good condition. This was an integral part of life in a log house. The color of the sealant often contrasted with the dark color of the logs, creating a characteristic striped pattern that became a hallmark of frontier architecture. White or light gray strips of clay against the backdrop of wood, darkened by time, gave the hut a neat and finished look. Thus, the caulking process was no less important than the construction of the walls themselves. It transformed a structure that was exposed to the elements into a warm and impregnable fortress capable of withstanding any weather. It was a technology that combined ancient knowledge of the properties of natural materials with practical ingenuity. The construction of the roof was the final chord in the construction of the hut, a kind of crown that completed the long work and turned the log frame into a real house. This stage required not only strength and patience, but also engineering ingenuity. The roof had to be both strong enough to withstand the weight of winter snow and completely waterproof so that not a single drop of rain could get inside. At the same time, the builders had only the simplest materials and tools at their disposal. And yet, using only an axe, a knife, and a rope, the settlers created structures that could stand for decades. It was a living example of how man turned limited resources into an engineering marvel. The roof construction was both simple and well thought out. Cross beams were laid on top of the upper wall logs, creating a rigid base for the future ceiling and attic. These beams distributed the load, preventing the roof from sagging. Then the rafter system was installed. Most often, this was a classic gable roof, simple to build and effective in operation. Two logs or thick poles were joined at the top at an angle, forming an isosceles triangle, and were firmly supported by the walls. Several such rafter pairs were placed at equal distances from each other and then tied together with longitudinal poles. The result was a stable, durable frame capable of withstanding not only its own weight, but also the force of wind and precipitation. At this stage, it was important not only to position the rafters correctly, but also to calculate the angle of the roof. A roof that was too steep could be dangerous during installation and required more material, while one that was too flat would retain water and snow. Experienced carpenters selected the optimal slope based on the local climate. In northern regions, roofs were made steeper so that snow would not accumulate but slide down under its own weight. In windy steppes, on the contrary, roofs were made almost flat so that they would not be torn off by hurricanes. This knowledge was not recorded in books. It was passed down from generation to generation. The most important stage was the creation of the roof covering. Everything depended on it: the warmth, dryness, and durability of the house. The choice of material was always determined by the surrounding nature. In the dense forests of the northern states or New England, roofs were covered with wooden shingles. These were thin plates carefully chipped from straight-grained oak, cedar, or pine logs. These species are not only resistant to moisture and decay, but also easily split into even, smooth plates. When laid correctly, such a roof could last 20 or even 30 years with almost no repairs. Making shingles required skill and patience. First, the wood was split along the grain with a special axe. Then thin, almost transparent plates were separated using a long-handled knife and a wooden hammer. An experienced craftsman could split 100 or 200 shingles a day, but thousands were needed to cover the roof of an average house. Therefore, this process took weeks and sometimes months. When the shingles were ready, they were sorted, dried, and only then were they laid. The shingles were laid in rows, starting from the bottom edge of the roof and moving upward. Each new row overlapped the previous one by more than half, forming a dense, multi-layered covering resembling fish scales. This principle was simple but effective. Rainwater flowing down the sloping surface could not get inside, even if there were tiny gaps between the plates. At the same time, the roof remained breathable. Air passed through the wood, preventing condensation. Thanks to this, the roof did not rot in winter and did not overheat in summer. But where forests were rare, for example in the steppes of the Great Plains, people showed remarkable adaptability. Here, settlers used a completely different technology: turf roofs. They took a frame made of poles and branches, covered it with a layer of bark or grass, and carefully laid layers of turf cut directly from the prairies on top. Each layer was about 10 centimeters thick, and they were laid in two layers: the lower one with the roots down, the upper one with the roots up. This allowed the grass to continue growing, binding the turf layers together like natural glue. Such a roof had amazing properties. It was heavy, but that was what gave it stability. It was not blown off by the wind, it did not freeze, and it retained heat perfectly. In summer, when the sun heated up the prairies, it remained cool. The layer of earth acted as a natural air conditioner. In winter, the turf retained heat, acting like a thick woolen blanket. However, this solution had its drawbacks. Turf roofs often leak during heavy rain, especially in spring when the roots weaken. After heavy rains, they had to be repaired by adding new layers or compacting the old ones. Despite this, for many settlers, it was the only way to build any kind of shelter. In some regions where there were no trees or turf, roofs were made of reeds, cane, or straw. Such material was light, but when laid correctly, it was also reliable. Straw roofs were laid in thick layers, up to half a meter, pressing them down with wooden slats. They repelled water well and retained heat, and with proper care, they lasted for decades. The completion of the roof was not just a construction stage, it was a symbolic moment. When a roof finally appeared over a log cabin or wicker wall, the house was considered alive. It may not yet have had a floor, windows, or furniture, but it already provided a sense of security. The moment the last shingles were laid on the rafters, the owner could say for the first time, "Now I have a home." It was a triumph of human labor and ingenuity, a victory over cold, wind, and time. The roof was more than just protection. It transformed a simple hut into a place where one could survive, keep warm, and start life anew. Every element of it, from the angle of the slope to the last splinter, was the result of experience and observation. This was the essence of the settler's life: to use what the earth provides to defeat the elements, not with force, but with knowledge and perseverance.
The kitchen could go right here, near the window.
It'll be perfect once we finish the walls.
When the walls and roof were ready, the hut was still an empty, echoing box. To turn it into a real home, the interior had to be finished. Floors had to be laid, and windows and doors had to be cut out and installed. These elements, which we take for granted today, were luxuries for the settler and required no less skill than the construction of the walls. The earliest and simplest huts had no floor at all. The floor was simply the ground, which was leveled, tamped down, and sometimes covered with a layer of clay. Such a floor was cold and damp, but for the time being, it was sufficient to survive the winter. It was the most basic shelter, which was inevitably improved over time. A more sophisticated and common type of floor was the plank floor, or puncheon floor. It was made not from sawn boards, but from logs split in half. These halves were laid on the earthen base with the flat side up, as close together as possible. The result was a sturdy but very uneven floor. The height of craftsmanship was to level such a floor. Using a special axe with a wide blade, a carpenter would chip away all the unevenness, achieving a surprisingly smooth and even surface. This work was very slow and difficult, requiring hundreds of hours of monotonous labor, but the result was worth it. Such a floor was warm, durable, and could serve several generations. Windows were rare in early huts. Any opening in the wall was a source of cold and weakened the structure. If windows were made, they were very small, more like loopholes. Of course, there was no glass. The opening was covered with oiled paper or thinly tanned and stretched leather. Such windows let in a little dim light, but did not allow you to see what was happening outside. The doorway was cut into the finished wall with an axe and a saw. This was a difficult operation, as it was necessary not to damage the integrity of the log structure. The door itself was massive and sturdy. It was assembled from thick planks fastened with crossbars using wooden nails or pegs. The door hinges and bolts were also made of wood. Metal products were too expensive and rare. Craftsmen carved intricate and ingenious hinges and locks from hardwoods such as oak or maple. These simple mechanisms were surprisingly reliable and durable. Each element of the interior was created by hand from whatever was at hand. Furniture, tables, benches, beds, was also made from roughly hewn planks and logs. Everything was simple, functional, and devoid of any decoration. The beauty of these interiors lay in their honesty and naturalness. The interior finishing process could take months or even years. Families often moved into a house that was not yet finished and gradually completed it as time and energy allowed. The hut grew and changed along with its inhabitants, becoming a true family nest. A finished frontier cabin was not just a building, it was a complex and self-sufficient system, a true machine for living, perfectly adapted to harsh conditions. The central element of this system, its heart and engine, was the hearth or fireplace. It provided heat for warmth, fire for cooking, and light for long winter evenings. The fireplace was built of rough stone, held together with clay mortar. It was a massive structure, often taking up an entire wall. Building a proper fireplace was a high art. It had to not only heat well, but also, most importantly, provide good draft so that smoke did not enter the room. An error in the proportions of the chimney could make life in the house unbearable. The whole life of the family revolved around the hearth. Here, food was cooked in heavy cast iron pots suspended on a special hook. Here, clothes were dried, tools were repaired, and in the evenings, everyone gathered together to talk or listen to stories. The fire in the hearth was a symbol of home, safety, and civilization in the midst of the wilderness. The log cabin structure itself functioned as a single organism. The massive log walls had great thermal inertia. During the day, they slowly heated up in the sun, and at night they gave off the accumulated heat, smoothing out daily temperature fluctuations. In summer, such a house was cool, and in winter, it was warm. The house constantly breathed and changed. The logs settled, the joints became tighter, the clay in the seams cracked and required repair. Life in such a house was a constant dialogue with it. The owner had to understand its needs and care for it as if it were a living being. This formed a very special relationship with one's home. Everything in this house was the result of the labor of its inhabitants. Every chair, every shelf, every spoon was made with their own hands. This created an incredible sense of belonging and pride. The house was not just property, it was part of the family, the keeper of its history. These buildings were incredibly durable. The secret to their strength lay in the quality of the materials and the right techniques. With proper care, a log cabin could stand for 100, 200, or even more years. Many of these pioneer huts have survived to this day, serving as silent monuments to their nameless builders. They were the pinnacle of pre-industrial engineering. There was nothing superfluous in them. Every detail was functional and justified. These houses were honest, durable, and beautiful in their simplicity. They taught people to live in harmony with nature, not to fight it. The legacy of these forgotten engineers is not only the surviving buildings, it is, above all, a lesson that the human mind, ingenuity, and hard work can work wonders, even without sophisticated technology at their disposal. It is a reminder of the value of manual labor and deep intuitive knowledge, which is becoming increasingly rare in our digital age.
The surviving buildings stand as monuments to the ingenuity and hard work of the frontier builders.
We can see that building a cabin on the frontier was not just a craft, but a true art that required deep knowledge in a wide variety of fields, from geology and botany to structural engineering and climatology. The settlers were engineers, architects, and designers all rolled into one. They created their homes out of primordial chaos, relying only on their experience, their axes, and their unyielding will. Their creations were not just shelters. They were the embodiment of the dream of a new free life. Every notch cut, every stone laid was a step toward that dream. These modest dwellings became the cradle in which an entire nation was born and raised. Their story is a hymn to human resilience, ingenuity, and the ability to create order and comfort in the heart of the wilderness. Which of the technologies used by frontier builders did you find most ingenious? Perhaps it was the method of leveling the foundation with a water trough, or the art of carving self-locking joints? Suggest topics for future videos that you would like to see on our channel in the comments. And don't forget to subscribe so you don't miss out on new research into the forgotten skills of our ancestors.